This is chapter 3-1, lines and angles. Please copy your codes. All right, in this particular chapter, just like in chapter 2, we are still dealing with proofs. Please be sure you commit to memory the definitions, the postulates, the theorems that are associated with this chapter. To begin, we're going to start with parallel lines, which are two lines that are coplanar that never intersect. So if this is my plane here, the rectangular shaped box, I have two parallel lines. Line L and line M, they are parallel. They will never touch one another. Or I can call this line AB and line CD. These two are parallel to one another. Please note that this is the symbol for parallelism. It looks like two lowercase l's. Or when people write it by hand, the symbol for parallel is usually a side word slash with two L's. So please be sure that you know the symbol for parallel. And here's my first definition. Line AB. And I can also do ray AB is parallel to ray CD if I didn't want to look at the endpoints. Or I can also call this ray BA is parallel to ray DB. Okay? Many ways we can call out that parallel line. If I hold up one sheet of paper and I call this my plane, here I have my plane. Okay? If the two pencils represent parallel lines, they're both on the plane, and again, they will never touch. They're going exactly the same direction. If I skew it, if I were to continue going, it would eventually intersect. So these would not be parallel. Same direction. Okay, the location may be slightly different for the two. Right, so please be sure you know that. Okay, here again, just some more information. I can call that line AB parallel to CD. This is also ray AB is parallel to ray CD. I can also call this line L is parallel to line M if I'm calling by its cursive letter. Okay. That also means that I can say line segment if I don't want to call it by the whole line. Line segment AB is parallel to segment CD, or any of the rays which I've also stated are also parallel. Skewed lines, my favorite, one of, very easy to understand. If you're in your book or you're not using our textbook, page 129, skewed lines are simply lines that are not on the same plane and they will never intersect. For example, if I have a cube here, if I have on my cube, skewed lines will be right here, this top corner, it faces this direction. And if I were down, that's this first plane up here, if I'm looking at this line. And then another skew would be this back edge over here. So I have them going two different directions. So here's my first line, if I'm just doing an extension, will go left to right there. And my skewed will go front to back down here in this bottom corner. If this line or this pencil were to continuously go, it would never intersect this red line which goes this direction. These two lines will therefore be skewed. Okay? Never ever intersecting. Okay? Parallel lines, some example, two planes you can also have, like you do have parallel lines. You can have two planes that will never intersect. For example, I have a red sheet of paper that represents one plane, and I have a purple sheet. These two planes are parallel to one another, meaning they will never intersect. They go the same exact direction. Okay, now if one is skewed this way, if I were to continue this purple one on top, it would eventually intersect at some point. Okay, it's curved or slanted. But when they're parallel, if I turn them this way, these are still parallel planes. They will never intersect. If I continuously kept these going, they will never intersect. Okay? I give the example of your front cover of your book and the back cover of your book. Those lines, or planes, excuse me, will never ever intersect. Okay? Parallel planes. Parallel and perpendicular postulates. Postulate 13, remember we talked about not memorizing postulate numbers, because if we transferred or use a different book, or you went to a different school in a different city or state, they may use a different book. However, you need to remember, you need to memorize the postulate or theorem. Okay, so we have parallel postulate, and this postulate simply says if there is a line and a point that is not on the line, which I'm going to show you here. So for example, if I have a line and a point, and this point P does not lie on L, there is only exactly one line that I can draw in order for point P to be perpendicular or parallel to line L. So if I want this point P to be on a parallel line to line L, there's only one direction I can draw it. For example here, if I have a line and I wanted P to go through it, if it was drawn this way, this is an intersecting point, therefore meaning this new red line that I've drawn does not or is not parallel. That won't work. If I took and drew it this way here, this would not work either. This new line, the red line I've drawn through point P, will eventually intersect line L if I were to continue that line on forever. So this does not work either. It will continue to go on, and if I extended the black line, it would intersect back here. That doesn't work. So there's only exactly one place that I can draw this new line. If I were to draw it, if I were to draw that line, like so, it'd have to be parallel, and that means that my new red line is parallel to line L, okay? One point, that point P goes through it, and that same red line is parallel to line L. There's only one way or direction I can draw that. Continuing on, postulate 14 is the perpendicular postulate. And that just says if I have point P and line L again, there's only one exact place that I can draw that line for my new line drawn, point P and L to be perpendicular. What do you mean? If I take and I draw this line, there's only one exact place that I can draw this line, my new red line. It goes through point P, and at the same time, it is perpendicular, meaning it forms 90-degree angles with line L. So my red line goes through point P, and it's perpendicular to line L. Watch this. Now, if I took and drew my line, my red line, even if I skewed it just a little bit like so, if I were to extend this red line downward, it would hit line L, but the thing is, it would not be perpendicular. So there's only one complete way I can draw my red line in order for it to be perpendicular. Continuing on. Identifying angles by transversal is easy if and only if you study and memorize the terminology. First of all, you need to know the definition of a transversal line. If I have this drawing here, like so, I'm out and delete. If I have this diagram drawn like so, my transversal is line T. It's going to cut two coplanar lines that will intersect at this point. So line T is going to intersect line M at this point, and it's going to intersect line P at this particular point. Okay? Line T will intersect these two different lines at two different places. It intersects line M here, and then transversal T intersects P down here. So they're intersecting at two different places. Look at the angles that I have. There are a total of 8. Those 8 angles have different meanings for their locations. Let's look carefully. First of all, let's look at angles 1 and 5. These angles are called corresponding angles because they occupy the same corresponding position. They're in the same position. 1 and 5 are corresponding. I also see that 2 and 6 are corresponding. They're in the same exact location as one another. So 2 and 6 would be corresponding. 3 and 7 correspond, and hopefully you see that the last corresponding set would be 4 and 6. Okay, they occupy the same corresponding position. Okay, make sure you know corresponding angles. Next we have same transversal T, cutting line M and line P. Next we'll look at alternate exterior angles. First of all, to know what alternate exterior means, you need to know what alternate means. And to know what alternate, you need to know that when I'm talking about opposite, okay? When I say alternate, I mean opposite. Exterior means outside angle. So I want opposite outside angles. Opposite outside angles. And again, 5 and 6 are the inside, so I couldn't possibly be talking about that. I can't be talking about 3 or 4. Those are interior. They're inside. So the only exterior angles could be 1, 2, 7, 8. And then I specified the exteriors that I want. I want alternate. So I want the opposite, the two opposite angles, which would be 1 and 8. So angles 1 and 8 are alternate exterior angles. I also see another set of alternate exterior angles, 2 and 7. Remember, exterior means the outside, so it's either 1, 2, 7, 8. But then when I say alternate, I mean opposite. So 2 and 7 will be the opposite outside angles. Okay? And again, alternate exterior angles both lie on the outside of the transversal line, that T. Okay? Moving forward. Still looking at transversal T, cutting line M and cutting line P. Looking at this transversal cut, okay, angles 3 and 6 because I'm looking at alternate interior. So opposite inside, you need to know the word. Interior is your inside. So I want the opposite inside this time. Angles. The question is, if I'm looking at interior, what am I talking about? I'm only talking about 3, 4, 5, and 6. They're on the inside. I cannot be talking about 1, 2, 7, and 8 because those are on the outside or the exterior. And when I use the word alternate, I mean opposite. So I want the opposite interior angles. The opposite interior are 3 and 6. They're opposite of one another, and they're on the inside angles. They both lie between 2 lines on the opposite interior inside of both of the transversal or the diagonal. Sometimes I say, when I say opposite, I mean the diagonal. They're diagonal to one another. So you may hear me say opposite or diagonal. The other set or pair of alternate inside angles or interior angles would also be 4 and 5. Angles 4 and 5. And finally, or next I should say, looking at the same transversal T, okay? The next thing I want to look at is consecutive interior angles. Consecutive means next to. I want the next to inside angles. Next to inside angles. There's the word interior, so I know I'm talking about inside angles. Consecutive means next to. Okay? And I don't mean necessarily 3 and 4. They're on the same side of the transversal. The key words is same side. Okay? The transversal I'm referencing is T. Yes, 3 and 4 are next to one another, but the thing is they have to be on the same side of the transversal, and that means 3 and 5 are consecutive interior angles. Remember, interior, inside. Okay, that cannot be 1 or 2 or 7 and 8. It's either 3, 4, 5, 6. In this case, next to is 3 and 5, and they're on the interior. And I also see another set of consecutive interior angles. That's angles 4 and 6. So angles 4 and angle 6 are also consecutive interior angles. And that's your 3-1 lesson.